We absolutely love the capability to zone within like a virtual storage area network in order to control what resources can access what other resources. Let's go ahead and examine in this particular nugget what could commonly go wrong with zoning and how we would solve it. But before we get there, what are the really efficient, straightforward ways to verify your zoning configuration? Now, before we get too deep here, just a couple of reminders about how zoning works. In fact, these could very well be the source of some frustration when you are working with zones, if you've forgotten any of these. First of all, we know there's the concept of a zone set. And a zone set can be activated or deactivated as a single entity across all the switches in your fabric. We can only have one zone set activated at any given time. A zone can be a member of more than one zone set, and of course, the zone itself consists of multiple zone members. Members in a zone can access one another. Members in different zones cannot access one another. Now, I got to tell you, when I started making a list for you of all the ways in which you can have a device be a part of a zone, I was super surprised that there were so many. And that's because I tend to do it. Most administrators are going to tend to do it using a particular method for their environment, and they never branch out from that. Now, many of us think in terms of going ahead and doing the zone membership with the port worldwide name. Certainly, we would go ahead and zone based on this. And of course, it's the device port worldwide name that we are talking about. This is of a node port, the N port that's attached to the fiber channel switch. But understand, we could also go with the fabric worldwide name. So this is of the F port of the fiber channel switch to which the device is attached. Another popular option, the fiber channel ID. Keep in mind that if you were going to do fiber channel ID of the N port attached to the switch, you would want to be doing static fiber channel ID assignments, of course, in your infrastructure. Now, I'll put an asterisk next to this one, or a star, because interface and switch worldwide name could be done, but keep in mind that this isn't an official standard yet. So you'd want to be very careful in areas of interoperability between vSANs, because you might get in trouble with vendor supporting. Just like the next one, domain ID and port number. You can do this, but vendors implement this in a lot of different ways, so you could get yourself in trouble in a multi-vendor environment. Zoning membership can be based on a device IP address. This form is really useful in iSCSI device environments. You could use a symbolic node name. This allows zone members to be defined by their unique symbolic node name, like an iSCSI qualified name or an IP address associated with iSCSI devices. Again, be careful, because there's a lot of different implementations of this, and you might have trouble in multi-vendor fabrics. And then finally, we could do fiber channel alias or device alias as our methodology of zone membership. Now, I'm sure you remember there's two ways in which to enforce zoning. There's soft zoning, short for software-based zoning, and hardware-based zoning, often known as hard zoning. Hard zoning is enforced through access control lists that the switch port ASIC applies to every fiber channel frame that it switches. Soft zoning is enforced by the fiber channel name service. When devices connect to a fiber channel fabric, they use the FCNS to correlate worldwide names to fiber channel IDs and to discover devices on the fabric. Keep in mind that a lot of devices these days from vendors will revert to soft zoning when a threshold number of zone members is actually exceeded. Also, keep in mind with new technologies that we have today, we have an expansion of how hard zoning can be carried out. You see, for the longest time, soft zoning was synonymous with worldwide name zoning, and hard zoning was synonymous with port zoning. You can no longer draw those lines, though, since many vendors, including Cisco, is able to do soft zoning in all kinds of different criteria environments. Now, we should also probably review some best practices when it comes to zoning in your environment. The first one used to be really super true and a long established practice because of the additional level of security it provided, but also it was a nice mitigation about bugs. What I'm talking about is often referred to as single initiator zoning. And what you do in this practice is you literally use as many zones as there are host bus adapters that need to communicate with storage. Now, this is not as critical as it used to be because, again, there's less firmware bugs and things of that nature that we have to worry about in our SAN environments. But really enhancing the number of zones that you use for your particular locking down particular communications is still considered a best practice. The second one is to simplify management. We really want to focus on using aliases whenever possible. The third really zoning practice best recommendation I could give you is taking your zone administration and confining it to one fiber channel switch within a given fabric. This ensures that there's no possibility of activating an incomplete zone set. Finally, the fourth recommendation, leave the default zone policy in your environment at a deny. This ensures that our devices don't inadvertently access each other when they are placed, for whatever reason, into the default zone. So you're in the data center and it's time to verify on a device what's been done as far as zones go. So I'm going to say show zone set, and remember we're always specifying our vSAN. So zone set vSAN, and I have a vSAN configured here of 117. And it says, okay, Anthony, you've got a zone set name set up of CBT zone set. It's for vSAN 117. And you've got a zone in there for CBT zone. So a CBT zone is in the CBT zone set. And then here we can see the devices that are members of this particular zone. But what I'm really interested in here is what's active. So I'm going to say show zone set once again. And we're going to follow that up, though, with the active active keyword, and then I'll specify my vSAN of 117. It says, okay, zone set name, CBT zone set vSAN 117. It's giving me this information again, confirming for me that it is particularly active. And then it shows me the member zone inside that zone set. Notice the asterisks. This indicates that these particular devices are visible and online. If you have a missing asterisk here, it might indicate an offline device or an incorrectly configured zone. Obviously, one of the great possibilities here is that you have a mistyped port worldwide name. But perhaps you're in a situation where you want even more details. Check this out. Show zone analysis active vSAN, in our case 117. Look at this. We're getting information on when it was activated, who it was activated by, what's that default zone policy that we spoke of, number of devices zoned in the vSAN, including the unzoned devices. I love it. Zone members resolved, the number of zones, IVR, IPS zones, great stuff. And now it's time to wrap up this particular nugget with a look at why a zone fabric merge would fail. Cisco's Technical Assistance Center says this is the most common area of problems that are reported when it comes to zones in the storage area network. First of all, one of the very common things, we've even discussed it in other nuggets here at CBT, that is domain ID conflicts. These can cause merge failures, so we need to make sure all the switches in our fabric have a unique zone ID. Oftentimes, zone merge failure is caused by incompatibilities in the active zone databases. If two fabrics have active zones with the same name, then the members of those zones must be identical. Something else to look out for is the vSAN allow list. If the vSAN allow list on an inter switch link is not allowing traffic to flow between switches, check the interface on both ends of the isolated ISL. If only one interface shows the isolation, then the vSAN that shows the isolation is probably missing from the vSAN allow list over the trunking expansion port. That, of course, is our TE port. Finally, if the vSAN is missing from one of the switches, a fabric merge does not occur because only vSANs with identical IDs can merge. So a simple example is our vSAN 117. It can merge with another vSAN 117, but not with a vSAN 120. And remember, if your zone merge does fail, you have three main options for recovery I need you to keep in mind. You can import the zone set database of the neighboring switch and replace your current active zone set. You can export the current database to the neighboring switch, or you could manually resolve the conflict by editing the full zone set, activating the corrected zone set, and then bringing up the link. Remember, you can use the simple commands for importing and exporting an active zone set. That is zone set import, and then just use your context sensitive help to be walked through that, or zone set export. And once again, you'll be walking through the context sensitive help for the remaining parameters you need in that particular command. So in this nugget, we took a look at none other than fiber channel zoning, specifically troubleshooting this important zoning configuration that we might even inherit from another administrator. I sure hope this nugget was informative for you, and I'd like to thank you for viewing.